In this question, you will be applying both principle of moments and Newton's second law. So it shows you a object, probably a ladder, or it's a ladder that is resting on a wall, and the wall actually supports the ladder with a normal contact force R that is perpendicular to the surface. That's why R is horizontal. There's a downwards weight of the ladder, and there is an upwards normal contact force by the ground on the ladder, S, that supports the ladder from the ground. So there's a force missing though, is a frictional force, and in part A you are to determine where the frictional force is acting. So the frictional force is drawn as such, is pointing towards the left, because the ladder has a tendency to slide down, and therefore frictional force opposes this intended motion, and hence frictional force direction is towards the left. In B part 1, you are to determine the weight of the ladder. That's quite easy because the mass is given to you, which is 20 kg. So use the correct formula, W equals to mg, to get the weight of the ladder in newtons. That's 200 newtons. Okay, in B part 2, you are to determine the value of S, the outward force. And in this case, I've used Newton's second law because in this whole ladder, it's in equilibrium, it's not moving, it's not rotating. So all the outward force, just one outward force over here, S, must balance the downward force. So S and W, these two values must be the same. That's what I used to solve the question. Now, not needed here, but you should note that all the rightward forces, which is R, must also balance all the leftward forces, which is F. So these two forces should take the same value also by Newton's second law when the ladder is not moving and it's at equilibrium. Now in part C, you are to solve for the frictional force using moments. So let's be, as per usual, be very clear about where the pivot is. That's always the starting step. Find the pivot point. I've used A as the pivot point, and I've again looked at all the forces remaining, which is the downwards weight. And this downwards weight, if this is the only force acting on the plank, it will want to rotate the ladder in a clockwise manner. So this is the moment. There is a frictional force which will want to make the whole ladder rotate in a clockwise manner also about the pivot. And lastly, the outward force S will want to push up on the ladder to make it rotate in a anti-clockwise manner. So I've color coded the three moments caused by the three different forces, and what remains to be done is, as per usual, plug it into the POM equation, and with that we can solve for the frictional force F to be 75 newtons.